So given that the mean is 0, so again, we're looking back at the equation. So if the mean is 0, that means tidying up the general equation, the half cancels out. So essentially b equals minus a, or a equals minus b. We're going to pick the second one, the red box, because it's going to be useful for part C. So find an expression in terms of b only, so i.e. a, make them equal, so eliminate a, for the expected value of 3x squared. Now 3x squared firstly can be written as 3 times ex squared, so a bit like the last line. But before we get there, what I did here is I used a certain relationship. I used a relationship between the variance of x, the ex squared, and the mean squared, because this is the general equation given. So we need to know this one by heart. Now all you really do is just plug and play everything you have. So we know the variance of x is a default formula. It's always 1 over 12 times b minus a squared. This formula is literally standard for uniform distribution. This is a fixed formula, it never changes. So plug it there. We also know that the mean is 0, so I plugged it there. We also know that a equals minus b, so I replace a with minus b, so it'll be b minus minus b, which is 2b. I tidied this up a bit, expanded it, and therefore ex squared equaled b squared over 3. Now, solving the question again, recapping, we had to find an expression in terms of b for the expected value 3x squared, yeah? So all I did is just whip out the 3 outside, because you can do that. And ex squared is b squared over 3. That times 3 is just, well, b squared.